Hello and welcome to part 4 of learning math from the ground up. Today we're going to learn variables and constants. The first 3 videos were about the fundamentals of the math, and right now we are getting into more complex side of the math. But don't worry, I will explain everything in great detail. A variable is a symbol or a letter like X, Y, or Z that stands for an unknown number. Variables are used to represent numbers in equations and expressions. For example, in 3a, the expression 3a, the a is a variable. 8z squared, z is our variable. Negative 53b, b is our variable. 20x cubed, x is our variable. And 1 over 9y, here y is our variable. Okay, now let's learn some vocab. Let's go down. Term. Each expression is made up of terms. A term can be a signed number, a variable, or a constant multiplied by a variable or variables. Well, basically what this is saying is that here, let's say that we have an expression called 5x squared plus 3x minus 8. This whole thing is called an expression, and each expression is made up of terms. So this is first term, this is second term, and this is third term. You don't need to necessarily number the terms, just know that each of these that are separated by plus or a minus is a term. Factor is something which is multiplied by something else. A factor can be a number, a variable, term, or a longer expression. If, for example, 6 and 2 are factors of 12, right? Because if you multiply 6 and 2, you get 12. At the same time, x minus 2 times x plus 3 are factors of x squared plus x minus 6. Okay, they're both factors. Coefficient is the numerical factor of a multiplication expression that contains a variable. So basically, if we have a term that is 7z cubed, in this term 7 would be our coefficient. Whatever, let's go up. In these examples, in these terms, 3 is the coefficient, and 8z cubed, 8 is the coefficient. Negative 53b, negative 53 is the coefficient. 20 is the coefficient, and 1 over 9 in this term is coefficient. So whatever you're multiplying the variable with, basically. Constant, a number that cannot change its value. So basically, if you have an expression 8x squared minus 5x plus 3. Here, the 3 would be a constant because you cannot change the value of 3, right? Depending on the x, however, the first term and the second term can change its value, right? If x was 1, this term would be 5, but if x was 2, it would be 10, right? And finally, like terms. Terms that contain the same variables are called like terms. So basically, 5y squared and negative 3y squared are both like terms because they both contain the same variable, which is y squared. On the other hand, 7y wouldn't be a like term because its variable is y, not y squared, like the other two. Let's do an example to understand it better. The question is asking for us to find the terms, coefficients, and similar terms. In this question, we're given two expressions. Okay, let's first identify the terms. Here on the left side, we have 6xy squared, which is one term, 7y, and 4x cubed is another term. Here we have 2x cubed, y to the 7, and 3xy squared. So we basically have, in total, we have 6 different terms. Okay, now let's find the coefficients. In the first term, 6 is our coefficient. In the second term, 7 is our coefficient. And here we have 4 as our coefficient. On the right side, 2 is the first term's coefficient. The second term's coefficient is, well, you don't see anything, but don't forget that there is invisible 1 here, right? It's being multiplied by 1. So -1 or 1 would be our coefficient. And here 3 would be our coefficient. You can include a negative to this coefficient or not, because negative is being multiplied by both of them, so it doesn't matter. And lastly, let's find the similar terms. Similar terms. On the left side, let's take a look. 6xy cubed. So we're looking for another term that also has xy cubed. Not on the second, not on the third. Let's go to the other expression. Not the first one, not the second one. Yeah, the third one, right? They're both, so both 6xy squared and 3xy squared. Both of them has xy squared, right? That's why they're similar terms. Let's see if we can find another pair, or it doesn't have to be a pair, it could be coupled, right? So let's go to the next one, 7y. Y is the variable. Do you see any other expression that has the y variable? If you choose y to the power of 7 like this one, that's not correct. They should both be the same variable. So I don't see another y. Let's go to the 4x cubed. Do you see another x cubed term? Yes, I do. So we have 4x cubed and 2x cubed. They're also similar terms, and I don't see any other similar terms. Let's go to these examples. The reason why we learn similar terms is that we can combine the similar terms. For example, here, all of these terms, these 3 terms, have the same variable. Therefore, they're all similar terms, right? So we can just combine them. There's like addition, so we can just do addition or subtraction, right? 2x plus 5x plus x would give us 8x. On the next one, we have 4k plus 2r minus 3k plus 5r. Well, I see 2 different variables, k and r, and I see some similar terms. So let's clean this up by adding and subtracting the similar terms. So we can add 4k to negative 3k, right? Which would give us a k. And then we have 2r and 5r left, which in total would give us 7r. On the next one, we have 2b minus 9b plus 5b plus 6b. Again, they're all similar terms, the same variable. We can just add and subtract. 5b plus 6b would be 11b, minus 9b would be 2b, and 2b plus 2b would be 4b. Here, the similar terms, here the variables s squared, and they're all similar terms. 7s squared minus 2s squared would be 5s squared, plus s squared would be 6s squared. Okay, don't forget to pause the video and do these questions by yourself first, and then watch the video. Okay, let's go to the next question. I see two different variables, x, y, z, and v squared. I could just add the similar terms. 5xyz plus 2xyz would give me 7xyz. Negative 7v squared plus v squared would give me negative 6v squared. And the last one, I have 4x cubed, I have an x cubed, I have x squared y, xyz, x cubed y squared, and a constant. I don't see any similar terms. That means that we're just going to leave it as it is, because you cannot combine and subtract anything, right? This here should be a plus, sorry. Okay, let's go to the next question. Okay, here's a new rule that we need to know. If the bases are the same in multiplication, the exponents are added. So basically, it's saying that if we have the same base, which in this example we have a as our basis, we have two a's, and they're being multiplied. So the final answer would be the same base and their exponents added. How did we get 2? If you have a, you have 1 here, and then 1 there. 1 plus 1 would be 2. Here we have x as our base, and they're being multiplied. So the answer would be x to the 2 plus 3. We're just adding the exponent, which is x to the 5. Let's do some examples. This is basically asking what is a squared times a to the 3rd. Well, to do that, we're just going to add the exponents because they're being multiplied and they have the same base. We're just going to write the base and add it, x to the 5. We have our base as x, and x to the 5 times x squared. We're just going to add 5 plus 2, which will give us x to the 7. Here we have 2y plus 3 times 2y plus 1. Same base, and they're being multiplied, so we're just going to add the exponents. 2 as our base, and adding y plus 3 plus y plus 1, which would give us 2 to 2y plus 4. This is 3m plus 1, sorry for the formatting, times 3 to the m. Same base, they're being multiplied, so just adding the exponents. M plus 1 plus m, which is 3 to the 2m plus 1. Don't forget to pause the video and do it yourself. Let's do this one. Which would give us 4 to the 2n, and minus 2 plus 1 would give us minus 1. Before we get to the last two questions, let's do one more example. Let's do this question. This one. So we have 5m squared n times 2mn squared plus 4m cubed n cubed, right? So let's do the multiplication first, because remember from the order of operations, multiplication comes before the addition. So we can first multiply the coefficients. In this example, it's 5 and 2, which would give us 10. Now let's multiply the variables. So basically we're left with m squared times n times m times n squared. If you remember from the second video, if you change the order of multiplication, the answer doesn't change. So we can basically swap this m and n to make it easier, to see it easier. So if we have the same basis, we're multiplying the exponent of this one is 1. So m squared times m would give us m cubed. We're adding the exponents here. We have 1 as well. And this would give us n cubed, right? We're adding the exponents. And we can't further multiply m and n, right? Because they're both different variables with different bases. So we're just going to write it as m cubed. We also had plus 4, so we're just going to write that as well, plus 4m cubed. So the answer would be 14m cubed n cubed. Okay, let's go to this one. If we're multiplying these two parentheses, we're just going to multiply each term in this parentheses with each term in this parentheses. So let's multiply 2k and 3k first. 2 times 3 would be 6, and k times k would be k squared. Let's multiply 2k with -1, which would give us -2k. 1, multiply 1 with 3k, which would give us 3k. And finally, 1 with -1, which would give us -1. Let's combine the like terms to make it look neater. 6k squared. -2k and 3k are like terms, so we can combine them, which would give us a k and -1. So our final answer. Here we have ab plus 1 squared. We can expand that as ab plus 1 times ab plus 1, right? That's the same thing. And now we can do the same thing that we just did and multiply each term, right? Which would give us ab times ab would be a squared b squared, right? Remember from this example, ab times 1 would be plus ab, ab times 1 would be plus ab again, and 1 times 1 would be 1. If we combine the like terms, the final answer is ab squared b squared plus 2ab plus 1. Now let's do a word question. It's saying that imagine a mobile phone with 8 different folders. Each of these folders contain B apps. Now without further ado, let's just understand what this part is saying. There are A folders and B apps. So how many apps in total there are in the mobile phone? To do that, you would multiply A and B, right? If you have 3 folders and 5 apps in each folders, it would be 3 times 5. You would have 15 apps in total, right? So let's just write that. AB here would give us the total number of apps, right? Now, if we add C new apps to the phone, okay, so we're adding C new apps. We have AB apps. We're gonna add C, okay, and remove D apps from every single folder. Now, we're not removing D apps in total. We're removing D apps from every single folder. If we have A folders and we're removing D apps from each, in total we would remove A times D apps, right? For example, if we had 3 folders and if we were removing 1 apps from each folder, that would give us 3 apps in total, right? So we can write that as minus AD, right? AD. What equation would represent the total number of apps left on the phone? Well, We just found it. This is our answer. Okay, let's do the next question. Determine the equation that represents the difference between the area of square A and the area of rectangle B. So, to find the area of a square, you would multiply two sides. But we also know that each sides are equal to each other in a square, right? So if this is A plus 3B, this is also A plus 3B. The area of square A would be area of square A. We can find it with multiplying two sides, A plus 3B, which is A times A is A squared, A times 3B plus 3AB. 3B times A would also be plus 3AB or plus 3BA, which are both the same thing, right? You can write it like this to make it easier. And finally, 3B times 3B would give us 9B squared. This is the area of square A. Now, area of rectangle B would be, well, to find the area of a rectangle, you would multiply the both sides. This side, we know it's 2A negative 2A minus B. And we know this side from the square that it's A plus 3B, right? So just multiply A plus 3B with 2A minus B. Let's multiply it really quickly. 2A times A would be 2A squared. A times negative B would be negative AB. 3B times 2A would be 6 6BA or AB. Same thing, because the order in the multiplication doesn't matter. And finally, 3B times negative B would give us negative 3B squared. We are not done yet. The question is asking the difference. So let's just... Okay, so this minus here would be multiplied by everything inside, because remember, if you're multiplying the term with the parentheses, you multiply it with every single term inside, right? So we can just first do this parentheses and get rid of the parentheses, right? Let's do 2A squared minus AB plus 6AB minus 3B squared. Now we're multiplying everything with the minus, this minus, right? We're going to multiply every one of them. So it's minus A squared minus 3AB minus 3AB is 9B squared. And we can finally combine the like terms. We have A squared here and there. So let's combine every like term. 2A squared minus A squared would give us an A squared. Okay, we did that. Now we have ABs here, there, and there. So let's combine all of the ABs. Minus AB plus 6AB would be 5AB. Minus 3AB would be 2AB. And we have minus 3AB here. So the final answer would be AB. And finally, I have 2B squareds. So let's combine those two. Negative 3B squared minus 9B squared would give you a minus 12B squared. This is our final answer. Let me check my algebra. Yeah, so it should be correct. So this is our final answer. Now let's do the final question, and we will be done for today. what is the result of the operation? Let's first do the top side. This part, right? Actually, I'll use a different color. Let's first do this part, right? So, we're multiplying two parentheses. We're going to multiply every single term in this parentheses with this parentheses. A times 2a would be a times 2a would be 2a squared. A times 3b would be plus 3ab. And minus b times 2a would be minus 2ab. And minus b plus 3b, sorry, minus b times 3b would give us negative 3b squared. And before we go to bottom, we can just simplify. Okay, actually, you know. At the bottom, we have a squared plus ab minus 3b squared. Let's combine the like terms of the top part. Now we have 2a squared plus 3ab minus 2ab would give us ab minus 3b squared. At the bottom, we have 2a squared plus ab minus 3b squared. As you can see, both are the same. So if you divide a number by itself, you would get 1. And that's our answer. Thanks for watching, and please subscribe for more videos.